This be like your karate thing. I'll get some crowd. I wonder if we're supposed to bow down to the, show respect to the winners.
Wouldn't say anything. Anyway, I'm a speechwriter in the Office of Legislative and Public Affairs, so I'm kind of on the other side here. A very strange experience indeed. But good morning. Welcome to NSF. We're here today, obviously, to honor the and help celebrate the 2010 class of presidential early career awardees in science and engineering for 2010, funded by the National Science Foundation.
Well, thank you all for coming. I really, this is the best job of the whole job of being a chair of career. There's a lot of hard work, but coming here and talking to you, I talked to several of you over the last year and exchanged emails, and I feel like I know everybody and personally and all their issues, but this is the best. I have to say that the committee, the Career Coordinating Committee, really serves as the advisory group, and 2 or 3%. So in this group of PECASE awardees, we have 10 of the 21 PECASE awardees are women, which is, and this is done throughout the foundation, so we don't try to manage in any special way. But I think it's pretty interesting when you get the nominees, you find out that 50% were women, which is probably twice as much as the success rate of women in the program. And also a lot of Benjamins in this group. And I actually looked to see how many Benjamins were awarded in this period, and it's also a success rate of 50%. As a program officer, I'm always proud when one of my awardees becomes a PECASE winner.
Sure, but I understand there is a tradition here, as Sonia just alluded to. We have, each of you have 2 minutes to thank your directors and your families and your producers and so forth. So you can talk about whatever you like, each of the awardees, I should say, not each of you in the room. You can talk about your families, your motivation.
By hand, so in my group we take an alternative approach where we try to breed robots. So in a similar way to how ancient humans bred domestic dogs from wolves and modern corn from maize, we use these similar techniques to try and breed populations of simulated robots in virtual worlds. And we breed these robots to exhibit ever more complex and capable behaviors. And then after breeding, if we're lucky, we'll try and build and manufacture a physical version of one of these capable and complex robots. As part of my award, we're now trying to build a web-based version of this system so that anyone can get online and breed robots and learn about biology, animal domestication, neuroscience, and robotics along the way. So I'd like to thank 2 program officers.
Oftentimes I don't know who's holding the leash. So, thank you so much. Before I start, I want to thank Sonia Esperanza for all the hard work that has gone on here with respect to the PECASE program, and a number of other colleagues, Myra Montrose, my colleagues in OLPA, and of course the research directors and various offices at NSF. The PECASE program is a very special program, and this is identifying the cream of the crop in the country, young scientists, young faculty members from around the country. And it's a very select group. This year there are 94 for all the federal agencies, 21 of them from NSF, and 16 of the 21 are here. Unfortunately, 5 could not join. So I'm really delighted to have the opportunity to offer my congratulations in person to those who are here, and equally importantly to their families and friends. because it's a great occasion. I want to say just a couple of words about the National Science Foundation. You may know this. Some of you may know this. NSF was founded in 1950. At that time, what was a revolutionary idea by Dr. Vannevar Bush, who wrote this report called Science, the Endless Frontier, which was submitted to the President of the US at that time. And the revolutionary idea was the following: basic discoveries in science and engineering take place and should take place in the universities. And the federal government has to be a catalyst in nurturing and supporting that basic discovery. Now it seems like something that's obvious, but at that time, when it was first submitted to the then President of the US in the 1940s, it was rejected. Then it was accepted, and NSF was created to support that notion in 1950. It just so happened that Dr. Vannevar Bush was the first Dean of Engineering at MIT, and I had your fellow PECASE winners who are sitting with you, not as your young colleagues, but think of them 20 years from now or 30 years from now. They're going to be Nobel laureates. They're going to be movers and shakers, and they are major policy makers. And some of you may even come and run the National Science Foundation. And so it's a wonderful group, and I wish you all the best. Given the economic climate we are in, and given the pressures that come on an agency like NSF from all corners, we are in a very difficult position to make choices. And I'm delighted to tell you that our entire senior leadership team of this foundation, the heads of various directors' offices, we feel very strongly, no matter what the budget is, no matter what the economy is, one of the things that we want to completely protect on grounds of principles, core values, is human capital development. That supporting young graduate students, postdocs, career awards, PECASE awards, as much as we can, no matter what the budget situation is in the next few years. And
Thank you, Dr. Jensen. Our next speaker is Dr. Benjamin Kerr from the University of Washington, funded by the Biological Sciences Directorate. He's receiving the PECASE Award for studies of pathogen-host coevolution as a function of transmission through contact networks, and for strong dedication to teaching and mentoring, especially the development of innovative curriculum materials and outreach to students in underrepresented groups.
Thanks so much. Well, I'd like to actually start with one of my earliest science memories, which involved hearing about work done in the 60s by American psychologist Stanley Milgram, who was interested in our social network. The motivating question here was, if acquaintances are links in the network, how many links would it take to get from one random person to another? Milgram estimated this distance by initiating chain letters, in which each letter recipient was instructed simply mail the letter to an acquaintance that was more likely to know the final target. And it turns out that this distance is only 6 links, which is the origin of the term 6 degrees of separation. Now, as a kid, this research has strange resonance with me, partly because the result was surprising. Despite the vastness of our global population, our social network brings us remarkably close to one another. But partly the result was empowering as well. One, through experimentation and observation, could come to know something new, something exciting, learn something about yourself, ourselves, our world. So the research in our lab shares some of its original motivation with Milgram. Instead of chain letters, however, we're looking at cases where the socially transmitted items are the causative agents of disease, viruses, bacteria, things that make us sick. We use mathematical and computer-based models as well as model host pathogen systems. We create miniature worlds where a model host, a bacterium in our case, and a model pathogen, a virus that infects the bacterium, move through social networks. Essentially, these created worlds are a network of microbial cities, and we can control the routes of transportation between those cities. What we find is that the structure of the network affects not only how many hosts are infected, but also the evolution of the pathogen. If a pathogen only has to move through a few links to get to susceptible hosts, then what we find is that it can evolve to become more damaging to its hosts, so that we have real-time evolution in these experimental systems. Now, evolution in the biological community is a unifying concept. It's been a divisive topic within the general public, and the reasons for this are complex, but part of this is due to basic misunderstanding, and thus reflects an education shortfall. And there actually are solid practical reasons to redress evolution education, given that some of the main problems we're dealing with infectious diseases today are evolutionary. The origin of antibiotic resistance, more virulent strains, the shift in host species from animals to human hosts. These are all evolutionary phenomena. Another major aim of our group is to develop education materials and modules to demonstrating evolution in action, and also to bring students into the lab from high school level up to graduate level, where they can witness microbes evolving in real time. Now, I should mention the majority of these students are women and are from underrepresented minority groups. This is something I'm very proud of. These students, besides learning about evolution as this socially relevant, experimentally tractable field, also, many of them haven't been given access to leadership roles before, simply blossom in that capacity in the lab. There's really no greater pleasure and joy for me than to see a student gain confidence through discovery this way. So this has been a really rewarding aspect. Now, I started by talking about social networks, and I'm greatly indebted to many people in my social network directly linked to me. My wife, for her unswerving love and support. My parents and brother are here today. I'm really thrilled about that. My father and brother for their inspirational passion for social psychology in the case of my dad, music in the case of my brother, he's a fantastic composer. And my mother is here as well, and I really want to thank her for instilling a deep love of learning when I was young, and also a great joy that comes in sharing knowledge through teaching. My mom was my first teacher and still far and away the best teacher I've had. I want to thank also the members of my lab, my colleagues, collaborators, without whom none of what I do would be possible. And then finally, of course, I want to thank the NSF for this incredible honor. I feel very grateful to be able to do something that I love in life, and this is just extremely touching to receive this award and recognition. So